Hi, I'm Paul Battaglia, and this is section 7.5. Now that students have looked at integration by parts, assuming that you may have skipped over sections 7.3 and 7.4, mainly because those aren't covered on the AP exam, we arrive at integration by partial fractions, and it's time to take students through the process of what I like to call undoing a least common denominator. Now, that being said, the essential question we would like students to be able to answer at the end of section 7.5 is how do we integrate more complex rational functions? I think where we're going to go first is we're going to try and point students to the decomposing process. They have to learn how to work with this. It goes hand in hand with handling the logistic growth model that they've seen earlier in the course. So students need to learn how to successfully decompose a fraction, and then they need to know how to work with the constants a and b before they go integrate. Now, to that end, what's important is that students try and figure out a nice convenient way to solve for those values. And I would just tell my class, you're looking to use convenient values of x so that on the one hand, the constant a will remain and b will go away so that you can get the value of a, and then vice versa. Now, example 1 does a great job of walking you through the process. And I think it's important to take the time for students to look at this process. Maybe they're not quite ready right away to deal with the integral, but that's okay. You see, this whole integration by partial fractions process goes a long way in addressing mathematical practice number 3. As students learn how to sequence procedures logically, they need to learn what's involved, decompose the fraction, find the constants a and b, and then integrate. Now, what's common here, since we're dealing with a rational function, is for students to see ln. But what's also common is for students to now assume that ln will always be part of that. Example 2 does a great job of showing how this isn't necessarily the case for each piece. You see, as a part of that integral, through the solution process, students will happen upon the expression 9 over x plus 1 quantity squared. And what's maybe not so obvious at first is that that particular piece doesn't involve a natural log at all. That's just a basic power rule problem. So we want to point students in the direction of using prior techniques as well as the technique that they encounter here with partial fractions. So finally, let's talk about a common error that we deal with a lot of times in recognition. So I'm going to give you an example. Give your students this, the integral of the quotient. X squared plus 1 on the top, x cubed plus 3x minus 4 on the bottom. Just let them go. And after a while, see if students are trying to work through that process using partial fractions. Because the reality is, it's actually just an integration by substitution problem. And this is the kind of thing that we've been stressing in class all year. Recognition, knowing that you have to use different techniques. And I like to throw that kind of problem in because, let's be honest, it's the kind of problem that maybe a student sees on a multiple choice question, and they wind up saying to themselves, oh, which technique is it? Which technique is it? So we go through the list of options. We try and start easy before we go hard. Personally, I would consider the partial fractions process a little harder than integration by substitution. So I'd look there first. And if they had done that, they'd realize that this example is easy to deal with. I hope these tips have been helpful, and I'm sure you'll find much success in section 7.5.